Yeah, Catherine?
Wait, I need to find it. We're doing the pages 15 and 17 right now, right?
No.
Okay, never mind.
Bethany, which one?
21.
21, okay. No, we're still looking at the 5 to 10 from yesterday. That was homework that we were going on over yesterday at the end of the period. 23. Okay, so let's start with 20B. So we went through and I showed you how to match those, like 15 to 18. Yeah, I remember that we asked in here. Okay, so let's look at 20B. So I think we left off with 19. So did anyone need 19 while it's up there? 20B wants you to sketch the solution curve. So they wanted you in A and B to sketch the one that went through 0, 1, and in B to sketch the one that went through -3, 0. So what you have to do is just follow the path of the slopes, because those little segments give us the slope at any point. It's not an exact science, like you're not going to maybe have it in the exact spot as someone else, but it's going to be relatively close. When I did part A through 0, 1, I kind of followed these slopes to just do my best to come up with a shape that would follow those slopes. Okay? Any questions on that? And the tough part of it, I know for me, is that I want like an exact, I want to know exactly, and you kind of have to follow them and do the best you can to approximate what that graph's going to look like. Okay, the next one was 21. Okay, so this is a very interesting looking slope field. They want us to see what's true and false, so let's just go through them. If y of 0 is greater than 0, okay, so we have to make sense of what this graph looks like. Here's the x-axis, okay, so this is the x-axis, and this is the y-axis by looking at the numbers. And they're saying if y of 0 is greater than 0, so y of 0, if it's greater than 0, then the limits of, and it's asking about the solution. Saying what is true about the solutions of the differential equation. So the solutions would be the path that the graph takes on, whatever graph we could see in there. So the first statement, if y of 0 is greater than 0, then the limit as x approaches infinity is 0, is false. Why is that false? Why is that false? If y of 0 is greater than 0. Yeah, when they're greater than 0, we're looking up, the slopes are going up towards infinity, they're not going to 0, okay? Why is the second one true? We're focusing in now between -2 and 0. Why is that one true? If y of 0, if it's between -2 and 0, then the limit as x approaches infinity is approximately -2. Why are we going to say that that's true? Brandon?
Because the slope at -2 is approaching 0, so it flattens out, so we approach 2 and never get there.
-2, but it's never going to get there, right? But as x approaches infinity, those slopes are going to get closer to that y value of -2. Good. Why is the third one true? For less than -2, the limit as x approaches infinity is also -2. Why is that one true?
The line would be increasing, so it's going up towards -2.
Yep. It's never going to get there, but it's going to get closer, so there's probably a horizontal asymptote there. Okay, so that one was a little tricky the way that it was written, so going through those three statements was good. So it had to be D. Those are my least favorite questions when you have to go through every single part, figure out if it's A and B, or A and B and C, or so on. Okay, 23, so let's take the most probably time. Which best represents the slope field for dy dx equals cosine of x? Tell me what this means. What are we looking for? When we look at the slope field, what are we looking to see? How does that slope field relate to that equation? What are we looking for? What's the slope field show you?
Kind of like a line, cosine of x.
Yeah, whatever. This would be when you do what? Solve for y, right? So if they give you the slope field for cosine of x, are we actually looking for the graph of cosine of x? We're looking for the solution that when you would solve that differential equation, whatever you get for y equals, we should see those general solutions in there. So which one would represent it? You could do this a couple ways. If you integrated, separated first, dy equals cosine x dx, what's the integral of the cosine of x? Sine, positive or negative? Positive, okay. So you'd either be looking for the sine graph, or you could do things like put in a 0, 0. The cosine of 0 is 1. So on these slope fields, everywhere I see 0, 0, I'm going to exclude the ones where I don't have a slope of 1. So I could immediately cross that one off. I could cross that one off. Oh, what was this one at 1? I can't even tell what E is. Let's look. Oh, it's negative, so cross that one off, right? So then I could look at another point if I wanted to. I could, just figure out another point that might work. But if I know it's between these two, I can pretty quickly see which one's going to be the sine graph. Is it going to be that one? No, you see that one's not doing the oscillating, so it's A. Any questions there? So going through some of those multiple choices, that kind of helped put that in perspective a little bit, especially how to figure out what the slope field is, because they shouldn't take long. Like this shouldn't take long at all as a multiple choice. You're kind of eliminating the ones, you're putting in a point, zeros and ones are nice points to put in, and then figuring out, crossing off, and then picking another point.